Very good morning students, welcome to my channel Miracles of Math. So in the previous lectures, we saw what is sum to n terms and also sum to infinite terms of a geometric progression. We'll continue the same topic, that is geometric progression. Today we will learn about geometric mean. Geometric mean. Remember what is arithmetic mean? We have discussed in a few lectures before. What is arithmetic mean? If you have, let us say, three numbers A, B, C, B, which all the three are in AP, okay, so then we say B is the arithmetic mean of A and C. Or what we have discussed, if there is a number A, there is a number B, if you want to represent or if you want to insert an arithmetic means between these two numbers, then also we saw how to proceed. That is about arithmetic mean. Okay, so the same concept will be applied to geometric mean. We'll see how to do that. So let us take a number A and a number B. Two numbers we are having. We are trying to find what is geometric mean of these two numbers. Geometric mean of two numbers. Let us take the geometric mean as C. I want to find the value of C. What is geometric mean? Meaning that all these three terms should be in GP. We have two arbitrary numbers. We want to insert one more number in between that so that all three will form a geometric progression. So see here, if the first element is A, the next element will be AR, the next element will be AR square. Is that correct or wrong? So if at all I want to find the value of AR, okay, I'll product these two. Tell me if I product these two, A into AR square, that means I'm doing A into the element B, the term A into the term B. So this is A square R square, which is AR whole square. AR is nothing but C square. Correct. So product of A and B will give you the term C square. I want the value of C. So C is simply equal to root over AB. C is equal to root over AB. So the geometric mean of two terms A and B, is root over AB. What is the geometric mean of 3 and 4? Root over 3 into 4, that is root 12. So if you have a term here, 3 root 2 4 will form a geometric progression. 3 and 12. I need one element between them so that it forms a geometric progression. So root over AB, root 3 into 12, root 36, that is 6. So check whether these three terms are in geometric progression or not. Yes. Common ratio is true as well as common ratio is true. It is enough to say that they are in geometric progression. So what is this geometric mean we are discussing is we need to insert one number between two unknown numbers or two given numbers. We need to insert one number so that all the three numbers will form a geometric progression. Correct. This is just very simple idea of inserting only one geometric mean. But my question is how to insert n geometric means. So that one we'll discuss. Okay, so let us take two numbers A and B. In between two numbers A and B, I want to insert n geometric means. I want to insert n number of geometric means or simply n number of terms so that the complete sequence is in geometric progression. Complete sequence is in geometric progression. Let us see what happens here. There are n geometric means and this is one element, this is one element. What are the total number of elements here? Total number of elements, n elements here, one element here, one element. Total number of elements now it is n plus 2 terms. The total number of elements are here now. It is n plus 2 terms. Correct. Okay. See here. We have, if you remember, in geometric progression, the last element, that is the nth term, we have A into R power n minus 1. Remember this one, A into R power n minus 1, where n represents the total number of terms. N represents the total number of terms. What about here? What is n here? N is now n plus 2. Don't confuse with that n and this n. Okay. Total number of elements is n plus 2. Now tell me, what is the last term, that is Tn plus 2th term? Yes or no? There are n geometric means, but the total number of elements are n plus 2. So what is n plus 2th term, which is the first element a into r power, r is a common ratio which we still don't know, r power n minus 1, n plus 2 minus 1, correct? In place of n, we have to substitute n plus 2. So it is a into r power n plus 2 minus 1 becomes n plus 1. So what is this? This is the t n plus 2th term, the last term, that is nothing but b. So b is equal to a into r power n plus 1, or we can say r power n plus 1 is equal to b by a, or r is equal to b by a whole power 1 by n plus 1. Why 1 by n plus 1? If you are having something like x cube is equal to 4, let us say. So what is x? X is equal to 4 power 1 by 3. This 3 will come here, becomes 1 by 3 in the power. So in the same way, r is equal to b by a whole power 1 by n plus 1. So what is this? This is the common ratio of that geometric progression. This is the common ratio of that geometric progression. Correct. I'm erasing all this. I'm just writing common ratio, and then we will try to see what are the other elements. So what we are having here, we have common ratio is equal to b by a whole power 1 by n plus 1. So now, what are we supposed to find? We have to find all the n geometric means. The first element is a. What is the next element? A into r. We should multiply with common ratio, right? For geometric progression. So I'm taking this number as G1. That is the first geometric mean which we want to introduce. G1 is equal to a into r. A into r. Yes or no? So it is a into r is b by a whole power 1 by n plus 1. That is the first geometric mean we want to find. What is geometric mean 2? G2, which is a ar, and this will be ar square. This element will be ar square. Correct. So a into r square, b by a whole power 1 by n plus 1 whole square, that becomes 2 by n plus 1. That is G2. So on, what is Gn? That is the last geometric mean, nth geometric mean. Nth geometric mean will be a into r power n. For 1 it is 1, for 2 it is 2, for n it will be n. A into r power n, which is equal to a into b by a whole power n by n plus 1. So this is the term for nth geometric mean, a into b by a whole power n by n plus 1. Okay, so with this we can find all geometric progressions in between geometric means in between two numbers, so that the complete sequence will form geometric progression. Let us take some examples, and you will understand better. And in examples, it is your wish whether you want to follow in this method, remembering this formula, or you follow with the actual method which we actually got this formula. I will tell you one thing. Okay, see here. Let us take a number 2 and 32. Okay. So I want to introduce three numbers between these two. I want to insert three geometric means G1, G2, G3 between these two numbers, so that all the 5 terms will be in a geometric progression. Now, if you go to the same formula, let us see what happens. So G1 is equal to 2 into a into b by a, 32 by 2, it is 16 power 1 by n. What is n? Please don't confuse with the total number of elements. N is the number of geometric means. N is the total number of geometric means. How many geometric means we need to find? 1, 2, 3. So n takes the value of 3. So 3 plus 1 is 4. So 2 into 16 is 2 power 4 power 1 by 4. So it is 2 into 2, that is 4. This is G1. What is G2? What is G2? Once you got G1, it's very simple. Okay. Here it is very simple. 2, then 4. If you calculate, that will be, next one will be 8. So how do you get that Z2? A into R square. A into, okay. So 2 into B by A. B by is again 1 by 16. 1 by 16 power 2 by n plus 1. 2 by n plus 1. What is n plus 1? N is 3. 3 plus 1 is 4. So it is again 2 into, we get it is 4. Just calculate that properly. 2 by 4 is 1 by 2. That means square root. Square root of 1 by 16 is, sorry, I have done some mistake. It's not 1 by 16, it's just 16. Square root of 16 is 4. From there you get the value of 8. And Z3, if you try to calculate the same way, 4, 8, that gives you 16. So it is 2, 4, 8, 16 and 32. And if you carefully check, all these will be in a geometric progression. All these numbers will follow geometric progression. Let us see one more question. Insert 5 geometric means between 576 and 9. Oh God, what is this? Between 576 and 9. Is there any relation between 576 and 9? We don't know. We don't want. We will just follow the procedure. Even if you doesn't remember the formula, it's no problem. We will go as per the procedure. Okay, see here. Insert 5 geometric means insert 1, 2, 3, 4, 5. G1, G2, G3, Z4 and Z5. Insert 5 geometric means between 576 and 9. Between 576 and 9. So we have these two numbers. So common ratio, how you will find? So common ratio, if this is A, okay, T n plus 2, what is n plus 2th term? N plus 2, that means n plus last term, that is 9. This term is equal to A into 576 into A into R power, okay, A into, we don't know what is R, A into R power n minus 1, A into R power, A into R power, n minus 1. What is this n? N is the total number of elements. What is n here? Total number of elements will be 1, 2, 3, 4, 5. This is 6, this is 7. So total 7 elements. 7 minus 1 will give you 5. 7 minus 1 will give you 5. Correct or wrong? That is the total number of elements. Total number of elements will be 5 plus 1 plus 1, total 7. 7 minus 1 will give you, sorry, 5, 6, 7. 7 minus 1 will give you 6. I have done a mistake here. Alright. So now tell me, is there any connection between 9 and 576? Any factors? 5 plus 7, 12. I think this cancels with 3. Let us check. Or with 9, if at all possible. Yes, even if with 9 it might cancel. Let us check. 9, 576. 9 ones, 9 6 are 54. And this is 3. This is 9 64s are 36. Very good. So we can cancel that. 9 ones, 9 64. So you'll have 64 into R power 6 is equal to 1. Correct? 64 into R power 6 is equal to 1. Basic calculation. So R power 6 is equal to 1 by 64, which is actually 1 by 2 power 6. That is the value of 1 by 2 power 6. So you can say R is equal to 1 by 2. Your common ratio is 1 by 2. So now it is very easy. You have 576. The next step will be 576 into 1 by 2. The next one 576 into 2 into 2. The next one 576 in by 2 into 2 into 2 cube. Next one 576 by 2 power 4. Next 576 by 2 power 5. 1, 2, 3, 4, 5, 6. And the last step, if you do 576 by 2 power 6, this value should be 9. Okay, so please try to check what is that value. So this is the required geometric progression. Now all these terms are the 5 geometric means. All these terms are the 5 geometric means. Let us see one more question. Alright, the next question is, insert 5 geometric means between 1, 2, 3, 4, 5. 5 geometric means between 32 by 9. Oh God, what a complex numbers these are. 32 by 9 and 81 by 2. Whatever numbers are, nothing to worry. You just follow your procedure. Your answer will be there with you at the final step. So we have Z1, Z2, Z3, Z4, Z5. So total number of elements are 7 elements again. So T7, the seventh element, which is equal to 81 by 2, which is equal to A into 32 by 9 into A into R power n minus 1, A into R power n minus 1, n being the number of elements, which is 7 minus 1 is 6. So can we find R from here? Let us try to see. So R power 6 is equal to 80, this one I am bringing this side, 81 by 2 into 9 by 32. 81 by 2 into 9 by 32. So what is this 81? Nothing will cancel here. This is 3 power 4, this is 3 square. So it is 3 power 6 by 2 power 5 into 2, it is 2 power 6. So it is enough. R is equal to 3 by 2. Done. Your answer is done. The first term is 32 by 9. The next term is 32 by 9 into 3 by 2, whatever value is. Next one, 32 by 9 into 3 by 2 whole square. 32 by 9 into 3 by 2 whole cube. 32 by 9 into 3 by 2 whole power 4. And then the last geometric mean 3 by 2 whole power 5. And the last one will be 81 by 2. So this forms the geometric progression of 7 terms. 1, 2, 3, 4, 5, 6 and that's 7. So please calculate these values to get the actual geometric progression. So this is about geometric means. We'll stop it here. In the next lecture, we will see what is the relation between arithmetic mean and geometric mean. We have discussed arithmetic mean AM. We also discussed geometric mean, but is there any relation between these two? So that we will see in the next lecture. So thank you so much.